Next is question number 66, which says that the value of pi r going from 1 to 21 minus 1 by 2 plus root 3 by 2 iota whole raised to the power r is, right? Now we can here see that the value that is written inside the bracket is omega, right? Hence we can directly write it as, let us say the sum is equal to s. So this can be written equal to omega raised to the power 1 into omega raised to the power 2 into omega raised to the power 3 up till omega raised to the power 21, right? So this can be written as omega raised to the power 1 plus 2 plus 3 plus up till 21, right? So this is an AP with common difference 1, right? So this can be written as omega n by 2 into first term plus last term, that is 22. So this is equal to omega raised to the power 11 into 21. So this is equal to omega cube raised to the power 77. Now we know that omega cube is equal to 1. So the value of this product is 1, right? So the correct answer will be option number 4. Next is question number 67, a question from mathematical reasoning. Which of the following is a contradiction? 4 options are given and we have to see which one of the following is giving us fallacy. Now to solve such question, we can make truth table, right? Now let us say this is P and this is Q. So we can take the truth values as F, T, F, F, right? Now firstly, let us check the first option, right? So firstly, let us find the value of P and Q, that is T, F, F, F. And the value of P or Q is T, 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 F, right? So the negation of P or Q will be F, 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 T, right? So the value of this, let us say this is T, this whole is T. So the value of T will be this and this, that is the value will be F, 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 right? So the first option is correct because this is giving us contradiction, right? So the correct answer is option number 1. Similarly, we can check the other options also. Next is question number 68, which says that the projection of the line segment joining the points A, that is 1, 3 and minus 2, and B, that is minus 2, 1, 4, on the line making equal angles with the positive directions of the coordinate axis is, right? Let us say this is the line AB and this is the other line. So we have to find the projection of AB on this line, right? Now we know the formula for projection, that is projection is equal to AB vector dot, let us say this is eta vector, so this is eta cap, right? That is the unit vector, right? Now we can easily find AB vector, which will be equal to minus 2 minus 1, that is minus 3 I cap, plus 1 minus 3 j cap, that is minus 2 j cap, plus 4 minus of minus 2, that is plus 6 k cap, right? So this is a AB vector. Now we have to find eta vector. Now this line is making equal angles with positive directions of the coordinate axis. Let us say the direction cosines are L, M, N. So it is given over here that L is equal to M is equal to N. Now we know that for direction cosines, L square plus M square plus N square is equal to 1. Hence from here we can say that L is equal to M is equal to N is equal to plus minus 1 by root 3. That is eta cap is either equal to 1 by root 3 I cap plus 1 by root 3 j cap plus 1 by root 3 k cap, or eta vector is equal to minus of this, that is we can write it as plus minus of this vector, right? So we have eta vector and we have AB vector. So now we can find the projection of the line AB on the given line. So this is equal to AB vector dot eta cap, that will be equal to plus minus 1 by root 3 taking common, minus 3 minus 2 plus 6, that is equal to plus minus 1 upon root 3, but projection is always positive, so we have modulus of this, so this is equal to 1 by root 3, right? So the correct answer will be option number 4. Next is question number 69, which says that limit x tending to pi by 3 cos of x minus pi by 3 plus sine of 2x minus 2 pi by 3 whole raised to the power cot of pi minus 3x. So firstly we will check which form it is. So when x is tending to pi by 3, this will be tending to 0, that is cos 0, that is 1, and this will give us 0. And in the power we will get cot of pi minus pi, that is cot 0. So we can see that the given form is 1 raised to the power infinity form. Now we know how to solve this type of limits. Let us say this is L equal to the given limit, right? So applying the 1 raised to the power infinity form, L can be written equal to e raised to the power limit x tending to pi by 3 cos of x minus pi by 3 plus sine of 2x minus 2 pi by 3 minus 1 upon tan of pi minus 3x, right? Now let us say the limit in the power, let us assume this to be equal to L1, right? So we can say that L1 is equal to limit x tending to pi by 3 cos of x minus pi by 3 plus sine of 2 times x minus pi by 3 minus 1 upon tan of, multiplying and dividing by 3, we will get 3 times pi by 3 minus x, right? So let us say that x minus pi by 3 is replaced by t. So this will be equal to limit t tending to 0 cos t plus sine 2t minus 1 upon tan of minus 3t. Minus can be taken out, so this can be written as minus tan of 3t. Now this is equal to, so this can be written as limit t tending to 0 1 minus cos t minus sine 2t upon tan 3t, right? Now here we can see that 1 minus cos t can be written as 2 into sine square t by 2, right? So this can be written equal to limit t tending to 0 2 into sine square t by 2 minus sine 2t can be written as 2 into sine t into cos t, that is 2 into cos t into sine t can be again written as 2 times sine of t by 2 into cos of t by 2 upon tan 3t, right? Now here sine t by 2 can be taken common, so this is equal to 2 into sine t by 2, and inside we are left with sine t by 2 minus 2 times cos t into cos t by 2 upon tan of 3t, right? Now applying limit on sine t by 2 by dividing and multiplying by t by 2, and similarly applying limit on tan 3t by multiplying and dividing by 3t, we can write it equal to limit t tending to 0, cancelling 2 by 2, we will get t upon 3t into, when we apply the limit, that is t is tending to 0, so we will get here sine 0 minus 2 times cos 0, that is 1, right? Now t and t has been cancelled, so this is equal to minus 2 upon 3. Now this is the value of L1, right? So to find the value of L, it will be equal to e raised to the power L1, that is minus 2 by 3. right? So the correct answer is option number 3. Next is question number 70, which says that the sum of real parts of the solutions of the equation z raised to the power 4 plus z cube plus 2z square plus z plus 1 equal to 0 is, where z is a complex number, right? Now we have to make its factors somehow. So let us rewrite as z4 plus z cube plus 2z square can be written as z square plus z square plus z plus 1 equal to 0. Now here it can be analyzed that if I take 1 common from here and if I take z square common from here, then we will get something in common. So let us try to do that. Z square is common, so we are left with z square plus z plus 1. Similarly, taking 1 common from here, we are left with z square plus z plus 1 equal to 0. So we have got a common factor here, right? So this can be written as z square plus z plus 1 into z square plus 1 is equal to 0, right? Now here for this we know that the roots are z equal to plus minus iota, right? And for this also we know that the roots are z equal to minus b plus minus under root of d, that is 1 minus 4, that is minus 3 upon 2 times 1, right? So the roots are minus 1 plus minus root 3 iota upon 2. So these are the 4 roots of this equation. Now we need the sum of real parts of this equation. Now this is purely imaginary number. So the sum of real parts is minus 1 by 2 plus minus 1 by 2, which is equal to minus 1. So the correct answer is option number